Hey folks, Ms. Gosling here. In this video, you're going to be learning about vectors and scalars. By the end of the video, you'll be able to differentiate between vectors and scalars. So let's go ahead and start by just talking about the differences between them. So a scalar is a quantity that only has magnitude. By magnitude, I mean size or amount, something along those lines. Vectors, on the other hand, have both magnitude and direction. So for a vector, we care about which way our thing is traveling, which way something is going. Some examples of scalars in physics are distance, speed, time, temperature, and work, while some examples of vectors are displacement, velocity, acceleration, force, momentum, and hopefully your life, which of course should have some sort of direction. In this unit, we're going to be focusing on distance, speed, time, displacement, and velocity. Though over the course of the year, you will be able to experience and study all of these different concepts. So let's go ahead and talk about how we can represent vectors, because you guys are probably used to representing scalars, since those are just numbers. So one way that we could represent vectors is by talking about their magnitude and direction in words. So for example, I walked 4 meters northwest, where 4 meters is my magnitude and northwest is my direction. Next, we could talk about magnitude and angle. So this is a little bit more specific, right? So I could walk maybe 4 meters at 72 degrees. So that's going to be, if I have my coordinate axis, I would be walking 4 meters at a 72 degree angle. So my direction is given by that angle. Next, we could use coordinates. So for example, I could walk 2 meters north and then 2 meters east. Or, as we sometimes represent this, 2, 2. So 2 steps along the x-axis, 2 steps along the y-axis. So you can see here I kind of flip my x and y. We're not going to worry too much about that. So next we can depict vectors as a picture. So what we would do is we would give an arrow with the direction of the vector, and we would have some way of depicting magnitude. So for example, I could say this is 4 meters long, or I could have this on a graph where the end of my vector is at 4 meters and the tail of my vector is at 0. Finally, when we're dealing with variables, so for example, velocity, the symbol we're going to use to depict a vector is an arrow over the top of the letter. So you can see the way I draw my arrows, I kind of don't add my second little line here. And I just do that because I think it makes it easier to read. You're welcome to draw your arrow like a normal arrow. Additionally, if you're looking at a physics textbook of some kind or a written document, you may just see your variable as a bold letter to represent vectors. You cannot do this handwritten because it's not very clear whether you're writing a bold letter or just happen to have a slightly darker, happen to be holding your pen slightly more tightly when you wrote that. So include some sort of arrow, as in one of these first 2 examples, to show that you're talking about a vector rather than a scalar. So takeaways. Scalars have a magnitude, while vectors have a magnitude and a direction. Some physics quantities are scalars and some are vectors. And there are many different ways of representing vectors. So from here, you have 2 paths. The first path is the path that I recommend, and that is a vector math review. So in the math review, there will be a video on multiplying vectors by scalars, a video on adding and subtracting vectors in both 1 and 2 dimensions, and a video on how to separate vectors into their component parts. So most of you will want to watch this review. This is very vital. Being able to understand vectors is vital to your success in this class. However, if you are somebody who has recently done a lot of work with vectors in, for example, a math class, you may feel that this review is not something you need, in which case you can continue on to displacement, distance, speed, and velocity once you have passed your mastery check on vectors. So there you have it, folks. You have just watched your first physics lecture. I hope this went well. Go ahead and learn a little more about vectors and give all of this problem solving a try. Happy solving!